All right, guys, today we're going to talk about angles formed by chords, secants, and tangents. So remember that a chord is a segment with endpoints on a circle. A tangent is a line or a ray or a segment that intersects a circle at exactly one point. So it just kind of skims the edge of the circle a little bit. And remember that a secant is a line that intersects a circle at exactly 2 points. So let's just kind of remind yourselves of that. We haven't talked about a secant a whole lot. A line that intersects a circle at exactly 2 points. You can have a secant segment or a secant ray or a secant line, obviously. So line AB is a secant line. And remember that segments and rays can be contained within an entire line. And again, I'm going to give you the basics of what you need without actually proving each of the theorems that we're going to talk about. So there's really, it kind of boils down to just two major ideas when we talk about angles that are formed by intersecting chords or intersecting tangents or secants. So the first one that we're going to talk about is an angle formed by two chords, two intersecting chords, and the angle lies in the inside of the circle, in the interior space of the circle. And that angle measure is half the sum of the intercepted arcs. When we talk about the intercepted arcs, we talk about the arcs that are intercepted by that angle that we're talking about itself. So we're talking about angle 1. And the arc that is cut by angle 1 is this arc that is x degrees. And the other arc that is cut by the angle that is vertical angles with angle 1, the arc that is y degrees. Okay, so we could express that a little bit easier by saying that the measure of angle 1 is half of x degrees plus y degrees. So it's half the sum of the intercepted arcs. The measure of angle 1 is half the sum of the intercepted arcs. Another good way to think about it in general is if the best way, because you're going to have a couple of these a little bit, you're going to have a few. One of the best ways to think about it is to imagine that you have something that looks like a plus sign, maybe to remind yourself that this is going to be half the sum of the intercepted arcs. And again, we could talk about angle 1 being right here, and x degrees for this arc over here, and y degrees for this arc over here. And angle 1, the measure of angle 1 is still half the sum of the intercepted arcs. But do remember that we are talking about sum, because there's another theorem about an angle formed by two tangents, two secants, or a tangent and a secant, and that angle that's formed lies outside the circle. And the angle formed by two tangents or two secants or a tangent and a secant that lies outside the circle is half the difference of the intercepted arcs. And so you may not be sure exactly which one you should subtract, but generally speaking, it's the arc that's further away minus the arc that is closer. Okay, the arc that's further away from the angle minus the arc that's closer. It will be the larger arc minus the smaller arc. So in the first scenario, we have an angle 1 formed by two intersecting secants is half the difference of x minus y. Again, half the difference of the intercepted arcs. Arc x should be further away from angle 1, and this arc that measures y degrees would be closer, and the larger minus the smaller. And again, when you have an angle formed by a tangent and a secant that lies outside the circle, then the measure of angle 1 is half the measure of arc x minus the measure of arc y. And so it's also the exact same relationship. And lastly, when you have an angle formed outside a circle by two tangents, same relationship exists. The measure of angle 1 is half the measure with arc x degrees minus the measure of this arc that is y degrees. This one kind of is a scenario that you could be presented with less information, so we'll talk about that one in particular in a certain example in just a minute. Let's practice some problems involving applying these two theorems that we have. Remember, again, that an angle formed outside the circle by two tangents, two secants, or a tangent and secant is half the difference of the intercepted arc, the further arc minus the one that's closer. And then an angle formed inside a circle is half the sum of the intercepted arcs. Okay, so that's going to be the important thing to remember. So in each case, when you're trying to work a problem, you want to consider, is this angle formed inside the circle or is this angle formed outside the circle? So in this problem A, we have x degrees for an angle that's formed inside a circle by two intersecting chords. So remember from the previous page of notes that the measure of that angle formed inside is equal to half the sum of the intercepted arcs. And if you prefer, instead of writing it as 1/2 of 46 plus 90, if you prefer to write it as 46 plus 90 all over 2, that really is the exact same thing. You just have to keep in mind that it means the exact same thing. It's no different. So x is equal to 136 divided by 2. So x is equal to 68 degrees. And that's an application of the first theorem. Now let's try the second one. So when we look at this problem B, we notice that we have an angle 20 degrees formed by a tangent and a secant. Tangent and a secant, and it lies outside, right? Since it lies outside the circle, then it must be half the difference of the intercepted arc. So which arc is further away? 95 is further away. Z is closer. Now we're looking for an arc, and we're not looking for the angle, but the relationship is still the exact same relationship. The angle outside is equal to half the difference of the intercepted arcs. Remember that we are subtracting because the angle formed is outside. So we're going to say 20 degrees is equal to half of 95 minus z. And sometimes you all don't like to deal with fractions quite so much. So if you'd like to get rid of that fraction right away, you can multiply both sides of the equation by 2. So if I multiply this side by 2, I multiply this side by 2. Anything you do to one side, you do to the other, and then it cancels. You're not having to distribute it on the right anymore. So now you have 40 degrees is equal to 95 minus z. And I'm going to go ahead and move the z to the left side to make it positive. So I'm going to add the z. I'm going to add z and add z. I'm going to subtract the 40 and subtract the 40 so that we get z is equal to 55 degrees. And that's the measure of that arc that is represented by z. Okay, next example. You focus your camera on a fountain. Your camera is at the vertex of the angle formed by tangents of the fountain. You estimate that this angle is 40 degrees. What's the measure of the arc of the circular basin of the fountain that will be in the photograph? Okay, so it's a really good idea to try to understand the perspective of the drawing that we have at this point. So in the photograph, you're looking at the fountain dead on as if you were kind of standing on the ground looking at it. But when you look at the diagram that's drawn, you're looking at a bird's eye view, right? From above. You're hovering over the image from above, and the camera's over here, and we have a 40-degree angle for the camera, and we want to know, well, how much of the front of that fountain, or how much of the fountain is going to be visible in the photograph if we're kind of looking dead on and not catching the whole entire thing. So again, think about the angle. The angle is formed outside the circle, right? So that means that the measure of the angle outside is going to be equal to half the difference of the intercepted arcs, right? Sorry, that looks so bad. Okay, but the problem is we don't know what this other arc is, right? We're not sure what is the value of this arc for the measure of arc AEB. So somehow we're going to have to represent that. The nice thing about when you have two tangents that intersect a circle, it divides the circle into how many total arcs. You only have two arcs. So if this arc is x, how can we represent the other arc? Remember, we've talked about this lots of times, especially with angles. Remember that if we have 90 degrees and we split it and we call this x, then we would call this 90 minus x. Well, how much is the whole entire circle? The whole circle is 360 degrees. So if you have the measure of arc AB is x degrees, then the measure of arc AEB would be found by 360 minus x, right? This whole entire arc is 360 minus x, and it's kind of a good idea to think about where's that coming from. If we knew the minor arc and we were looking for this major arc, we would just subtract it from 360 degrees. So now we have everything we need to try to set up in this problem to solve for what we want. So the measure of the angle itself that's formed outside is 40 degrees, and it's going to be half the difference. What's the arc that's further away? That's 360 minus x. And then the arc that's closer is minus x. There's only one term there that I have to subtract, so I don't need to put it in parentheses. If you really like to, it's okay. We can use double parentheses there. It's not that big a deal. I'm going to do the same thing. I'm going to multiply both sides by 2 just to make this easier for you to work with and make this 80, get rid of the fractions. This is going to become 360 minus 2x. It's definitely a little bit easier for you to keep your variables positive, so we're going to add 2x, we're going to add 2x, and we're going to subtract 80 and subtract 80, and then we get 2x equals 280, and x is equal to 140 degrees. And that's the measure of the arc of the part of the fountain, the visible part of the fountain. Okay, so visible arc of the fountain measures 140 degrees. All right, let's try a couple of problems that are a little more challenging. Obviously, I would prefer that you try to do these on your own before checking, but maybe you can just pause it a minute and try some on your own. But definitely be thinking about, if you're looking for the measure of angle 1 and you're looking for the measure of angle 2, remember, you want to think about, like, what types of angles are these? What are they formed by? Are they formed by chords? Are they formed by tangents and secants? Where do they lie? All of those things come into play. So I'm going to try to find the measure of angle 1 first. Looks like this angle is formed inside the circle by two intersecting chords, chord segment ED and chord segment CF. So the measure of angle 1 is equal to half. If it's formed inside, remember that it's half the sum of the intercepted arcs. So the intercepted arcs, I'm looking for what gets cut by angle 1. That's arc EC, 70 degrees, and its vertical angle over here, arc FD, is 50 degrees. So that's going to be half of 70 plus 50, which is half of 120, which is 60 degrees. So the measure of angle 1 is 60 degrees. And we're good to go. Let's talk about angle 2. Angle 2 is an angle formed outside the circle. It looks like two secants. Chord EA is a secant, chord CA is a secant, and angle 2 formed outside the circle is half the difference of the intercepted arcs. Remember, it's half the difference of the intercepted arcs. So where are those intercepted arcs? Those would be arc EC and arc DB. So I'll write it all in symbols first. The measure of angle 2 is equal to the measure of arc EC, because that's the one that's further away, minus the measure of arc BD or DB, either one, all over 2. The measure of angle 2 is what I don't know, so I'll leave that as an unknown. And the measure of arc EC is 70 degrees. And the measure of arc DB is 26 degrees, all over 2. So that's going to be 44 degrees divided by 2. And the measure of angle 2 is equal to 22 degrees. And you're done with that one. All right, let's try a slightly different problem. Now let's try to find some arcs. Now we're going to try to find the measure of arc BD and the measure of arc BC. This sometimes can get a little more challenging because it's hard to tell, well, what information should I use? So let's look at where arc BD is. So here's arc BD, and it's intercepted by a couple of things. Well, it's definitely intercepted by this angle, angle BFD. which measures 100 degrees. It's also intercepted by this angle over here, arc angle A, formed by tangent segment BA and secant segment DA. So it's kind of challenging sometimes to tell what to use, but we'll see if we can get there a little bit. Let's give it a shot. Since I'm trying to find the measure of arc BD, and if I were trying to use angle A, I don't know the measure of arc BC. That's also unknown, so I probably will avoid using that. I think I'm going to go ahead and try to use the angle formed by two chords that's intersecting inside the circle because I know the measure of this other arc, CE. So it's hard to discern all the information that you should tear apart and use, but you just have to try to figure out what can you set up and what relationships do you know. So the angle formed inside is the measure of angle BFD. That's the 100-degree angle, is half the sum of the intercepted arcs. Remember, half the sum. So half the measure of arc BD plus the measure of arc CE. And the reason really why I'm going to go ahead and use this one first is because I already know the measure of this angle is 100 degrees, right? I'm looking for the measure of arc BD. I don't know that, but I do know that the measure of arc CE is 66 degrees, all divided by 2. If you don't like the 2 there, let's multiply both sides by 2 and make it 200 is equal to the measure of arc BD plus 66, so the measure of arc BD is going to be equal to 134 degrees. And now we've found the measure of arc BD. Let's go ahead and put that in our picture now that we know what it is. The measure of arc BD is 134 degrees. Sometimes, remember, you have to use information that you find to find something else. The other thing that we want to find is the measure of arc BC. Well, where's that? So let's put a question mark on the measure of arc BC. So if the first relationship that I had set up had used the 40-degree angle, then I would have had 2 unknowns. Let's look at that relationship a little bit right here. So this 40-degree angle formed by a tangent and a secant outside the circle cuts off this arc BC and also cuts off arc BD. So if we had set up this one first, it would have looked like this. The measure of angle BAC is equal to the measure of arc BD minus the measure of arc BC, all divided by 2, because remember that angle formed is outside the circle, so it's half the difference. But if we were trying to set this up and we put in the 40 right here, but we were looking, if we were looking for the measure of arc BD first, we didn't have either of these measurements known. So we had to find the measure of arc BD using something else first. So now we have 134 degrees minus the measure of arc BC all over 2. Let's go ahead and multiply both sides by 2. Get rid of that right there. Then we have 80 equals 134 minus the measure of arc BC. And then we'll add the measure of arc BC to the other side and subtract the 80 and get 54 degrees for the measure of arc BC. And you're done. So that's going to take care of angles formed by tangents and secants and chords. What we haven't talked about is segment lengths. And so in the next section, we're going to talk about segment lengths, but it's going to definitely be applicable in some of the assignments that you have to do. And that's it for angles formed by chords and tangents and secants.